Alright, next video. So we are in the Module 4 packet. We are in week 3 and pages 6 and 7. Let's get started. A soccer ball is kicked from the ground, that's a piece of information that's important, and reaches a maximum height of 48 feet after 4 seconds into its flight. Draw a rough sketch. Okay, so we got a picture. We have y-axis and x-axis. This time it was shot from the ground, so we're going to start here, goes up, and then back down. So this coordinate, we know that it's going to be 0, 0, and it's 0 height, 0 seconds, so our x value is going to be seconds or time. And this is going to be our height. Something about highest point, something about where it lands. We know that the maximum height is 48 feet in 4 seconds. So our x and our x represents time, so we're going to put the time, 4 seconds first. And then our y represents height, so we're going to put the 48 right here. Determine the function in vertex form for your soccer ball. Okay, so we know what vertex form looks like. That's going to be y equals ax minus h squared plus k. We're going to put in everything we can. So we know that our h is right here. We know that our k is right here. And then we need to pick something for our x and our y because we don't know what the a value is. I'm going to pick our 0, 0 point. So let's plug in everything we know. 0 equals, I don't know a, 0 minus h, which is 4, squared plus k, which is 48. And we need to figure out what a is. So let's start solving. 0 equals a, negative 4 squared plus 48. 0 equals, negative 4 squared is 16, so we're going to put it as 16a plus 48. Move the 48 over. Divide by 16 on both sides. Then we are going to get a equals negative 3. So let's put everything back together. We have y equals negative 3 times the quantity of x minus 4 squared plus 48. Cool. So there's our equation. Let's go see what the next question says. What is the height of the ball 7 seconds into flight? So 7 seconds, that's saying an x value. What's happening when x equals 7? So we're going to put x equals 7 into our equation. And solve. We get negative 27 plus 48. That gives us 21. So what does this mean? This means at 7 seconds, the ball is 21 feet in the air. Oh wait, let's do the next one. These ones, there's a bunch of different ways of solving, so I'm just going to go with whatever I see first. We're using all of our rules. I'll try to write down what rules I'm using on the right hand side. So I'm going to start by doing the power rule. And this is the one where you take the number on the outside and you apply it to everything on the inside. Don't forget that the 3 has a 1, so you have to put that to that 1 as well. So let's do a rewrite. 2 to the 3rd power, x to the 21st power, oops, and then z to the 0 power, my next step, I'm going to be doing the product rule. I'm also going to simplify as I go. So this right here is actually 2 times 2 times 2, which is 8. And this is actually 9. So I got 8 times 9, which gives me 72. X to the 21st, x to the negative 10 becomes x to the 11. So I just add them. Y to the 12, y to the 12 becomes y to the 24th. Z to the 0, z to the 8 becomes z to the 8. And we're done. This next one, I'm going to start by doing the quotient rule. I also know that 18 divided by 3 is 6. X to the 12 and x to the 4, if I subtract their exponents, I get x to the 8. Y to the 7, y to the 9 becomes y to the negative 2. Then I can't have a negative 2 exponent in my answer, so I'm going to apply what I know about negative exponents. This entire piece is like over 1, so what I'm going to do, I'm going to hop this guy down and rewrite it as 6x to the 8 over y to the 2. Okay, next question. More simplifying as if we would see it in quadratic formula. Let's take a look at this negative radical. We can't take the square root of negative radicals, so we have to bust this up as 36 times negative 1, which is really 6i. So if I do a rewrite, 8 plus 6i over 2, I then see what can be divided out by that 2. This gets rewritten as 4 plus or minus 3i. Done. Next one, this one's a little bit more difficult because 48 is not a perfect square. And this becomes square root of 16 and 3. For whatever is divisible by the denominator, so this piece and this piece. Just a reminder, you don't have to simplify what's inside the radical with the denominator. So this becomes negative 6 plus or minus 2i radical 3. And that is done. Alright, last problems of the video. We can do this. We are just going to be solving for x by doing opposite operations. answer. Okay. Now this one has a couple of options, so it's in standard form, so we can either, let's see, we can either put it in factored form by doing a diamond problem, or we can do AC method or box method. We could do vertex form, but we would have to complete the square, or we can do quadratic formula. Pick your poison. It doesn't really matter which one you do. I like doing factored form because it's the fastest. If I can pull a 2 out of everything, and then try to figure out what times, let's see if factored form even works. So we've got 10 and a negative 4. Unfortunately, that one doesn't work, so maybe I won't do it this method. Maybe I'll try completing the square. Pull a 2 out of everything, or just the first two terms. X squared minus 4x, leave some space, plus 20. Going to do half the middle term, then square it. So that gives me negative 2 squared, which is 4. Bring everything down. Then redistribute. So now I've got 2 times x minus 2 squared minus 8, because I'm multiplying this times that. And we get plus 20. Now I've got remember, this is all equal to 0. And now I can solve. And that would have been our final answer. So this one kind of works, but maybe if you want to do quadratic formula, you wanted to see how that would be. You could end the video right now or just watch the quadratic formula. So we've got a, b, c, 2, negative 8, and 20. So we've got negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So negative b would be negative 8 plugging everything in. What would we get? So this would be 96.